Alright, we're going to do some review on trigonometry, and you'll see that I've already cleared the RAM on my calculator as if I'm just starting a quiz or a test. So the very first thing that you need to do is second plus, that's to clear it, isn't it? What I mean is go to the mode and go down to radian degrees. We need to change the calculator into degrees mode. And you're never going to need radians mode. You must be in degrees mode throughout the exam. Remember that your calculator resets to radians mode every time that we reset its memory. So you've got to put it onto degrees mode. Okay? So degrees, great. Alright, number one. Got a water tower. Height of the tower is 26.5. So this distance right here then is going to be 26.5. meters, and we're told that from point A, the angle of elevation, which we know is measured from a horizontal, is 28 degrees. So 28 degrees right there. So we've already done part A, haven't we? We've shown and labeled the angle of elevation 28 degrees. Part B, calculate, correct to the nearest meter, the distance x. Alright, I can see that x is the adjacent side and 26.5 is the opposite side relative to the angle that I've been given. Opposite over adjacent in SOHCAHTOA, because it's a right triangle, comes from the tangent ratio. So the tangent of the angle, remember the angle always goes with the sine, cosine, or tangent. Tangent of 28 degrees equals opposite over adjacent, which is x. Now we need to get x by itself. Maybe I can bring the x up to this side of the equation first by multiplying both sides by x. And then I can get x alone. The opposite of multiplying by tangent of 28 is to divide by tangent of 28. Let's type this into the calculator then. What do we get when we take 26.5 and we divide it by the tangent of 28 degrees? We discover that we get 49.8. Oh, it says correct to the nearest meter. So that's going to round to 50 meters, isn't it? So approximately 50. And don't forget your units of meters. Alright, number two. We've got a diagram of an equilateral triangle ABC, 3 centimeters, 3 centimeters, 3 centimeters. By the way, an equilateral triangle, you might remember, is 60 degrees, 60 degrees, 60 degrees. I'm just filling in all the information I know. The side BC is extended to D by an additional 4 centimeters. Okay, gotcha. So this entire length is in fact 7 centimeters. We need to calculate the length of AD. I'm going to call this x for the sake of simplicity. Well, now if this is a 60-degree angle, that must make this one right here a 120-degree angle. In this triangle ACD, it's not a right triangle, so I cannot use SOHCAHTOA or Pythagoras. However, I could use the cosine law. I can't use the sine law because I don't have an opposite pair. Look, I've got side, angle, side. And you remember that with SAS and SSS, you cannot use the sine law because you don't have an opposite pair. So let's use the cosine law. Okay, so x squared is equal to 3 squared plus 4 squared minus 2 times 3. This formula is in the booklet, but you're going to need to know, if you're solving for a side, write that side down first. That's the x squared alone on the left side of the equation. If you were solving for an angle, your formula booklet actually has got an alternative version of the cosine law. This is cosine of 120 degrees. So I'm going to type this thing into the calculator. Then we've got, oh, wait a second. I forgot. I've got x is going to be equal to the square root of all that stuff, right? So I'm going to create the square root first. So the square root of, and here we go, 3 squared plus 4 squared minus 2 times 3 times 4 times cosine of 120. And I'm done. And I've got 6.08. Okay, so x is equal to 6.08 to 2 decimal places. That's right. And don't forget units, centimeters. Let's move on to number 3. We've got a diagram with a triangle. We've got all 3 side measures. We've also got an opposite pair. It's obviously not a right triangle, but when you've got an opposite pair, you'll probably find the sine law easier to use. So look for those opposite pairs, opportunities to use the sine law. If you have a right triangle, don't even bother looking for an opposite pair. When you got a right triangle, just use SOHCAHTOA. But when it's not a right triangle or you don't know, then look for an opposite pair. At any rate, part A asks us to find the area of the triangle. Now I don't have the height of this triangle. When you're being asked for the area of a triangle, we've got 2 formulas, 1/2 times base times height. But we don't have the height here, so we can't use this one. The other formula that you've got for a triangle is 1/2 AB sine C. Now in this situation, in fact, the angle that we've been given is actually angle A. So perhaps I should rewrite the formula to be 1/2 BC sine of A. The point being is that the 2 sides that we are multiplying together are the ones on either side of the angle. So the angle that we use, it must be in between the 2 sides that we're going to use in order to calculate the area. So here we go. So area is going to equal then 1/2 times 14 times 8 times the sine of 110 degrees. So here we go. 0.5 times 14 times 8 times the sine of 110 degrees. We get 52.6, and that's meters squared because it's an area. Okay? Let's find the size of angle ACB. And if you haven't seen that notation before, it's an old IB notation. This means the same as angle ACB. The point being is that the angle is at C. Well, we already knew that because it's in the middle of the 3-letter angle, isn't it? It's always the angle at C. So let's find the angle at C. Okay, so ACB. Okay, to find that angle, we could use, we've got the opposite pair. So probably sensible to use the law of sines. And so let's look at that opposite pair. Sine of 110 degrees over its opposite partner of 18 should be equal to, alright, we're looking for the sine of this angle, sine of, let's call it angle C, divided by its opposite partner, which is 8. Alright, so you'll notice that because we're looking for an angle, the variable is the thing that's inside the sine, because a sine always is followed by an angle. Alright, at this stage we should cross multiply. So we've got 8 times the sine of 110 is equal to 18 times the sine of C. And now we'll divide both sides by 18. So these ones cancel, and we've got sine C alone. And then in order to get the C alone, we obviously have to take the sine inverse of everything that I had on the left. So let's type that all in. The inverse sine of 8 sine 110 divided by 18. You'll notice how careful I had to be about parentheses. I needed to close off my parentheses on the sine of 110, and it's that entire amount which is being divided by 18, not just the angle. So close off the parentheses when your angle is finished. And now I'm going to close off my other set of parentheses to show that my overall expression is finished for C, and my angle is 24.7 degrees. Number 4. Got a rectangular block of wood with face ABCD. leaning against a vertical wall like in the diagram. AB is 8 centimeters. BC is 5 centimeters. And angle BAE is already indicated as being 28 degrees. Find the vertical height of C above the ground. So C above the ground, well, that's going to be the same as this, isn't it? So in fact, if I could just find the values of FB and BE and add them together, then surely I would have the entire height that point C is above the ground. Okay, this entire height here. So that's my goal then. I'm going to try to find FB plus EB, or BF plus BE, whichever. Well, to do that, I've got two different right triangles I can work with. So let's first find BE. In this triangle, let's call it X, we're trying to find something relative to the angle, which is the opposite, and we've been given the hypotenuse. Opposite and hypotenuse are related by sine. Sine 28 degrees is opposite over hypotenuse. And if I bring the 8 up to the other side, my x is now isolated. 8 times the sine of 28 is 3.75577. I'm going to make it to all of those different place values. I like keeping extra place values when it's not yet my final answer. It means that I am less inclined to lose accuracy in my final answer, which I can then round to 3 significant figures. I now need to find this other one. So I've already found BE, that's great. Now let's look for BF. That's going to be this length up here, which is a part of this triangle. Now we've got a little bit of a problem because we knew what one of the angles was in the lower triangle, but we don't have any of the angles in the top. But let's just go through this logically for a moment. If this is 90, and this is 28, that gives a total so far of 118. And we know that there must be a total of 180, so 180 minus these 118 leaves you with 62 degrees. This is of course a 90-degree angle because it's a rectangular block of wood. And so far we've got 152 degrees. 152 degrees, there remains only 28 degrees. I can find this by doing 180 minus the 62 and the 90, which I've already used, and that leaves me with a 28-degree angle. So after all, I am able to find an angle in this little tiny triangle. And so relative to this angle of 28 degrees, I need to find its adjacent side, which I'll call y, and I've been given its hypotenuse. Adjacent to hypotenuse are related by cosine. So the cosine of that 28 degrees is equal to adjacent over hypotenuse. Let's bring the 5 up to the other side, and then we'll be able to solve for y. So 5 times the cosine of 28 gives us 4.41474. 4.41474. And lastly, we're going to add these two values together, x and y, and we'll end up with the entire amount, which represents the height that C is above the ground, okay? X plus y. So let's add these two amounts together then. We've got 3.75577 plus 4.41474 gives us a total of 8. If I round to 3 sig fig, then my total height is 8.17, and my unit is centimeters. And we'll continue with 5 through 8 on the next part of this video.